I remember.
Okay, so let's look at about unit circle. Were there any parts that you felt you need more work on, or is one part harder than the other, or does everything kind of feel? Does it feel like everything makes sense in terms of building?
Pretty solid.
Okay, so good. So hopefully you're getting faster. Hopefully you're getting better at this, and then we're going to practice every day at the beginning just to get that additional practice. Yeah. Exactly. Yeah, I'll give you a blank sheet where you can at the beginning of the quiz or test. You'll give a blank sheet. You can fill that out. You use that unit circle to answer questions on it. Okay, so no questions. Everybody good? Everybody check their answers. Okay. All right. So we use the unit circle. This will come in handy as we go into page 30. Okay, so we have to go to page 30.
Yeah, count 100. Most people don't. I think so. I'm finished this night. I literally saved it.
You're gonna say, oh,
Oh, that's so cool.
All right. Couple of things that I want to point out before we. Okay, a couple of things I want to go over before we talk about the other trig functions is I want to give some definition here. So we'll use, we're not going to fill this unit circle out again, but I want to use the space to kind of add some notes. Okay, so we know that everything within our order pair comes as cosine and sine. So we kind of have an idea that if you look at the x value, that's where you pick off your cosine information. And then when you look at the y value, that's where you pick off your sine information, right? If I want to find the sine of an angle, I look at the y value of my order pair, where that angle is, and that'll give me the ratio. Okay, so cosine is for the x, sine is with the y. Now tangent, okay, tangent is opposite over adjacent. So opposite over adjacent essentially it's just going to be sine over cosine. So tangent is y over x. Now, let me do this here. I'm going to put, I'm going to line everything up like this. And I think this will kind of help us see the relationships and also allows us to see how everything is kind of connected with sine and cosine. If we have the order pairs for sine, which is x and y, which is sine and cosine, then we can find everything else just relying on information from the order pair. So we know that cosine is your x, sine is your y. And maybe you've heard of another trig quality here, that tangent is the same thing as sine over cosine. Okay, so you kind of put that to the side. We're going to see that tangent is equivalent to sine over cosine. So that means that that tangent is just this y over x. So we can just take, if we line it up this way, then y over x is your tangent. Y divided by x. So I think we're most familiar with sine, cosine, and tangent. So I like to kind of have that in the first column. In the second column, these are the ones that we're less familiar with. These are cosecant, secant, and cotangent. Okay. So cosecant lines up with sine. Secant lines up with cosine. And then cotangent lines up with tangent. I think most people are okay with cotangents because the word tangent is in this cotangent. So most students know that there is that relationship there. But I think these kind of get mixed up in terms of some people feel like cosecant goes with cosine or secant goes with sine, but cosecant goes with sine and secant goes with cosine. So what is the relationship? Well, cosecant is just the what of sine. Yeah, reciprocal. Okay, so whatever sine is, we just flip that. So to represent that, we can just call this 1 over y. So if I take the y value and if I take the y order pair and if I flip it, that's my cosecant ratio. Okay, secant would be what? 1 over x. And then cotangent is x over y. So we'll use this a lot. This will kind of help us quickly get the information that we need from the unit circle. Okay. Now, something else that I think is helpful, if you guys can create a grid here. So I think this just kind of adds on to the positive and negatives of each quadrant. So we know which quadrants, where the signs are for each quadrant, right? First quadrant is positive, positive. Second quadrant is negative, positive. Third quadrant is negative, negative. And fourth quadrant is positive, negative. And that's all fine and good. But I think it's helpful to know which trig functions have what, the signs that are associated with each trig function. Okay, so there's this acronym here that could be helpful. This is not a true statement, but this is what I use here. So you can say AS. B, C. And then, one way that we can represent those is you say all students take calculus. Okay, it's not a true statement, but that's just something to help us remember these letters. Okay, so ASTC, all students take calculus. So how does this help? Now, the way that this helps is because if we have this diagram to the signs, you know what we expect from each trig function in terms of whether we should get a positive or a negative. Okay, so A means all. So that means all trig functions will be positive in the first quadrant. Okay, so all are positive, if you want to write that. Now S represents the fact that only sine is positive. And that's a quick way for us to understand that, okay, if only sine is positive, then that means what's negative then? Cosine is negative and tangent is negative. Okay. Now, that's not a completely true statement because sine is not the only thing that's positive. There's also something else that's positive. That's what? Cosecant, right? So anything that is the reciprocal version of it also falls into that category. So if you want to put in parentheses cosecant, it's also good. So sine and its related trig function are the only ones positive, and everything else will be negative. What do you think T stands for? Tangent. So here, only tangent is positive. Which means that sine is negative and cosine is negative as well. But what else is positive here, though? Tangent. And if sine and cosine are negative, that means that cosecant and secant are also negative. So basically, any trig function is going to take its reciprocal and it'll follow that reciprocal. All right, and then what does C stand for? Cosine. So that means cosine is positive in the fourth quadrant. Which means that sine is negative and tangent is negative. But there's also one more thing that's positive, and that's secant. Yeah, secant is positive. So this is nice. It just kind of helps us confirm whether we're on the right track with sines, so that it's an extra step to so that we don't mess up the signs, right? We have this chart. We can quickly look at the trig function and decide what we are, what the sign should be depending on which quadrant we're living in. Okay. All right. Okay, so I'm going to throw this unit circle up here so I can quickly refer to it, and then you guys just fill one out, so have it next to you as we do this. All right, so using the unit circle, we're going to see if we can answer each of these questions here. Sine of 30 degrees. Sine is the y value. If you want to put to the side here, or somewhere on your unit circle as a reminder that your y value is your sine, and then your x value is your cosine. So sine of 30 degrees will be 1/2. Yeah. Number 2, cosine of 45 degrees. Yeah, √2/2. Cosine is the x value, so cosine of 45 √2/2. Tangent of pi/6. Okay, so let's talk about this. So tangent of pi/6, we know that we're looking at this order pair here. And what's the formula? It's y/x. Okay, so I want to kind of show the full thing first, and then I want to show the thing that we can ignore to help speed this process up a little bit more. So technically, it's 1/2 divided by √3/2, which is messy. Okay, but if we go through the reciprocal process, the 2's will end up canceling out. So what you can do is you can just cross the 2's out and just make it what? 1/√3. Okay, so here is the shortcut that I want you to maybe consider using is whenever you're doing y/x, cover up the denominator because those would just go away. And just make it 1 divided by √3. That makes sense. Okay, because the 2's will go away. I mean, you can do this whole thing, but it's just going to go away. So cover up the denominator if you're ever doing tangent or cotangent, and then just do y/x that way. So 1/√3. So that's a quick way to kind of get that answer, but we are going to rationalize the denominator. So what can we do to clean this up a little bit? Okay, multiply top and bottom by √3 just to get that rationalized denominator. Any questions so far? Okay. All right. Cosecant of pi/3. Cosecant of pi/3, we find pi/3. Now cosecant is related to what? Sine, which means we're talking about the what? The y value. And what are we going to do with the y value? Yep. We're going to flip it. Okay. 2/√3, right? So does that make sense? So we're everything is here, but we have to make sure that we're knowing where to look and knowing when to flip. So that's the ratio, but we can clean it up a little bit by doing what? Rationalizing. Good so far? So really, we just have to we just have to find the information on the unit circle, right? We've done the hard part. We filled out the unit circle. Good, cotangent of 90. Okay, so we find 90 degrees. Okay, what's the formula for cotangent? X over y. So what is that going to be? 0 over 1. Okay, so how do we interpret 0 over 1? That's a real number. That's 0. 0 over 1 is a real number. That's 0. Okay. Secant of 270. Secant is related to the x value. What do we do with the x value? Good, we flip it, right? So think of 0 as 0 over 1, right? And if I flip it, it becomes 1 over 0. And how do you interpret 1 over 0?
Undefined.
That's undefined. That's undefined.
You get 4 again.
How did I get?
Number 4.
Good. Okay, so how did I get 4? So 4, okay. Cosecant of pi over 3. So I find pi over 3, which is here. Cosecant is related to what? The x or the y? The y. So cosecant, we look at the y value. And then 1 over y means I'm going to take my y value and I'm going to flip it. So root 3 over 2 is where I'm looking, but because this 1 over y, I got to think, okay, if I see 1 over y, that just means reciprocal. So instead of root 3 over 2, I'm going to make it 2 over root 3. But the radical is in the denominator, so I got to rationalize it, and that becomes 2 root 3 over 3. Good. Okay, are we clear the distinction between 0 and undefined? Okay. Good. Okay. Okay, go ahead and try 7 through 10, and then I'm going to work through the same time that you guys work through. Okay, so try 7 through 10. I'm just not going to talk and have you guys try it. Okay, let me go over 7 and 8. So 7, cosine of 2 pi over 3. We know cosine is the x value. So you're going to just copy that x value down, negative 1/2, no adjustment needed. Cosecant of 3 pi over 4. We know cosecant is related to the y value, related to the sine. So we look at our sine value here, but what do we need to do because it's cosecant? So we got to flip it, right? So instead of root 2 over 2, I got to make it 2 over root 2. But technically this is the right answer, but we want to try to do some cleanup. So to do some cleanup, I have to multiply top and bottom by root 2 over root 2.
Wouldn't it be 1 over root? I mean, 1 over 2, 2 over 2.
Yeah, so okay, so I see what you're saying. You're saying 1 divided by root 2 over 2.
Yeah.
That's the same thing as just flipping it and saying 2 over root 2. So yeah, don't try to make it too complicated. Don't put 1 over that value. Just think when you see 1 over x, 1 over y, just take that fraction and flip it, okay, rather than doing 1 divided by 1/2 or 1 divided by root 2. Which just adds another level of complexity that we don't really need to worry about. Yes.
Can I go to the restroom, please?
Yeah, go ahead. Okay, now, when you get to cotangent and tangent, I have a little bit of something that I think is helpful. And that is cover up the denominator before you divide whichever way you want to divide it. Okay, so let me go through what I think is a helpful step. So cotangent of 2/10, so you find 2/10. And what's the formula for cotangent? Well, good, yeah. So tangent is y over x, cotangent is x over y. So you know you got to involve both the x and the y value. So what I want you to do is I want you to cover up the 2 and completely ignore the 2, and now do x over y. So what's x over y going to be now? Yeah, -√3 divided by -1, and that just allows you to not have to worry about the 2 because you know the 2 is just going to go away on its own, and it just saves an extra step. So I encourage you guys to use that little bit of a shortcut, especially when you're dealing with tangent and cotangent. Just cover up the 2 and pretend like it's not there, and then go through with your fraction. Okay, any questions so far? Okay, keep going. Okay, any questions 7 through 12? Everybody okay? No questions?
Here's an 11.
Yeah, 11. So tangent of 360. So let's look at that tangent of 360. We know that same thing as 0 degrees. And we know tangent is y over x. So y over x is just 0 divided by 1. And 0 over 1 is a real number, so we want to leave it as 0. Okay, so are we good with that? So now hopefully we're comfortable with all 6 trig functions within the unit circle, whether it's degree or radian. Okay, so now 13 through 18 requires an additional step from us because these angles may not be recognizable. So we're going to use our previous knowledge here. We're going to try to find a coterminal angle that lives in the comfortable region that we are comfortable with. So that means if something is out of range, you know you can always subtract or add 2 pi or add or subtract 360 to get into that comfortable range. And once you get into that comfortable range, then you can use the unit circle. Because right now these angles, we don't really, it's hard to know exactly where it is. Okay, so you can use your calculator for this, but I'm going to kind of just work through each of these steps with you. Okay, so let's think about 11. Yes, question. So think about 11 pi over 3. If you think about 11 thirds, it's outside. It's greater than 2. So what can I do to get it into that range. Subtract 2 pi, right? Or subtract 2. If I subtract 2, that's the same thing as, in terms of common denominator, 6/3. I get 7/3, oh, sorry, 5/3. And if 5/3 is the same thing as 11/3, we know we're good because we know what 5/3 pi is. So I'm going to rewrite this. This is the same thing as cosine of 5 pi over 3. So now that you have something that is clearly between 0 and 2 pi, now we can just go to our unit circle. Cosine of 5 pi over 3. Cosine is the x value. That makes sense. So we have that additional step of trying to get that coterminal angle into something that we recognize, because right now it's hard to recognize it without because it's rotated around the circle more than once. So negative 390, what can I do to get into the range that I can recognize? Add 360, yep. Okay. Negative 30, can I just wipe out that negative and call it 30? No, I got to keep going, right? I got to add another 360. I want something between 0 and 360. If it's not quite there, I got to keep going. Good. So cosine of 5 pi over 3. 5 pi over 3 is in the 4th quadrant. Cosine is the x value. Okay, next up, sine of 330. Is everybody good? How we got from negative 390 to 330? So sine of 330, we find 330 here. Sine is the y value. Negative 1. $13.05, that's a pretty large number. I'm just going to use my calculator and just going to keep subtracting 360. I did that a couple of times and I see 225 and I recognize 225 as an angle that's clearly between 0 and 360. So I have this thing with tangent, right? With tangent, I want you to cover up the denominator. And now what can we do? What's the formula for tangent? Y over x. So negative root 2 divided by negative root 2. Right, y over x. And what's that going to equal to? Yes, question.
Are we gonna be allowed to use our calculators for this part?
So if I give you something slightly outside, if I give you anything outside the interval, it'll just be either one rotation away. So either have to just add or subtract 360 once. I won't give you a large number where you got to keep. Huh? Yes, you got to do it in terms of radians. Well, something in terms of radians, you got to do it in terms of radians. So it's really just you're just adding, subtracting 2 pi, and you can just find common denominator. All right, any questions so far? 13 through 15. Okay, 16. 19 pi over 6. That's clearly outside my interval, so I can subtract 2 pi. And if I subtract 2, what's my common denominator? That will be the same thing as 2. 12 over 6. 19 over 6 minus 12 over 6 equals 7 over 6. we should be able to recognize that as something we see in the unit circle. That's going to be in the third quadrant. 7, 5, or 6, cosecant is related to the sine. Sine is the y value. So what do we do with that y value? Flip it. So what happens if I flip -1/2? -2. 17, -135 is not inside the interval, but it's close. We just add 360. Okay, 225, that's in the third quadrant. Secant is related to the cosine. So I look at the x value. And what do I do with this x value? Flip it, yeah. So -2/2. Rationalize. Okay, one last one here. Cotangent of -3π/2. It's not inside the interval, so I got to add 2π to that. And what's a common denominator that has the same thing as 2? 4/2. And that gives me 1/2, which is π/2. Cotangent of π/2. That's my 90-degree angle here. Cotangent. Okay, what's the formula for cotangent? X/y. 0/1. That's a real number. Any questions? All right. We'll pick this up tomorrow, okay? Guys, I don't have homework in this class. If you do what you're supposed to do in the class and you're comfortable, you're good. Your class will get your homework, so I'm giving you credit each day because I'm seeing you do the work.
But here, I was gonna ask you, you just add the crazy part to pi, if it's not.
And then once you do that, then
do it with the corresponding.
yeah, then you can find something on there.
I got the last question right, and I changed it. I just have to work. Right answer was, which was like. Oh, we had different, Bro, you're just getting like very small. About 6 feet. If you were. Yes. What? It's the same thing. Literally asked the same question. He gave us the question. I got checked on the next one. You're thinking of you're thinking of what? Testing ground. Ready? I have that. Did you hear me? I just got a question.